Okay. Uh, yep. I guess I'm live. Hey everyone, I am Ashish. Welcome to the AI Bootcamp. So today in this video we will be looking at opencv and some computer vision things really. So first thing first, we're gonna go to Cookie Sensei. Then we're gonna launch our labs. And today I will show you from the very start like how things happen in the labs. Just because it has been quite a lot of time since I logged in into the labs. So I've logged out into the labs. So today I will log in, GitHub clone, and show you the how and show you the entire process. Control Shift P. I'm gonna select color theme, default dark modern. Yep. Then I'm gonna go to my GitHub, select the repo, then copy this code, and I will say git clone, not clone, it's clone. And then paste the URL, and then I will clone the GitHub repo. Yes, this is my computer. Looks about done. And I will say change the directory to 14-day bootcamp, and inside there, list, and we're gonna go into the additional tutorial section. So CD 6 additional tutorials, and let's list out. Okay, this is where, and everything is IPYNB over here. Mostly everything is IPYNB. So 14-day bootcamp, additional tutorials, image manipulation, opencv. All right. So because I've just logged in, so if you run it right now, it may not run these things. Select the kernel. I will select perhaps data science kernel. Installing Jupyter and Python extensions. Fair point. Choose a kernel, Jupyter kernel, and show me a Jupyter kernel, please. Torch ATS data science. Yep, DS for data science. And module, no module named image.io, so I will install it. I've left some modules to on purpose, I mean, to not install them because just to replicate real world scenarios. Because if every package is installed, then you wouldn't even know or maybe remember how to install packages or work with packages. All right, np.ones create for me an array of 5 by 3. Then image is nothing but pixel brightness value ranging from 0 to 255, and I'm multiplying the array by 255. Then I'm saying make these specific elements 0. So now this thing, if you look at it carefully, this thing looks like a shape of 3. Does it? Okay, let's visualize it. Now does it look like a 3? Okay, now does it look like a 3? No. Oh, let's continue then. Mm. By the way, there is this glob kind of a library which says asterisk means match any character, hyphen match any character dot JPEG. So it's matching into one directory dot JPEG. So after this, I want to go inside one directory, which could be anything really, and match any JPEG images. So in the resources section, match any JPEG over there. That's what it means. Okay, what's this file doing over here? I might have mistakenly put it over here. Let's see. Linear regression simplified with mathematics. Okay. All right, let's come back where we were. We were right here. We were discussing glob. So over here, os.path.join resources tom jpeg. The first image that we had over here, resources, not the first, but the second one. Resources / tom.jpg, and this image we will load using opencv or pil or image.io, whatever uh, suits us. OS create for me a path, join the path from resources folder to tom.jpg and call it the command line interface path. CLI means command line interface path. So right now is the entire string for the path. Now I'm gonna say import pill. So pill is Python what? Python imaging library, something like that. So dot image dot open this particular path and print it using the display function. Just like we have a print function, we have a display function to display things like anything really. So it's just a print function display. This is something. So this is something, and this red squiggly line is there because I mistakenly put a white space over there. So this is nothing but a print function. So I could very well say this is another string. Yep. So right now we are printing, but the image looks too big to be, practical. So we're gonna try different ways of loading up the images. So over here, the second way to do the same thing could be that if you have an image over at internet. So this image also exists at my GitHub over here. So GitHub Cookies say AI tutorial. This is some other repo that I have over there. I've uploaded this image just to showcase that if you have a local image, you can upload it. If you have image over internet, you can use that as well. And the process is the same. Image URL, just put URL equals image URL inside the image function and display it. And there you go, displayed. All right. So what I'm gonna do right now is not convert actually. All images are nothing but 3D arrays. So to demonstrate that, I'm saying image.io, image read, Tom Cruise path. This particular path, read it. Now image.io will read it as an array. This is, I believe, NumPy array. So image.io.im read the path and display. So take a look. Initially, we had the image as the print. Now we are having the array. Don't be confused. Both are the same thing, really. It's just that we are in the PIL case, we were printing or plotting the image internally. So matplotlib also can see if you have an array like this, you can just use plt.imshow and image show plt.show, and the entire picture will be visualized or plotted for you. Okay, so now we're gonna use OpenCV cv2.imread image read this particular path, and OpenCV also reads your images as an array. And this is better because when we want to visualize the image, we can always call PLT, we can always call other things to visualize it. But image is nothing really but array. You don't, always visualize the images. You work with arrays of images. So over here, what I'm saying is, first of all, I've read this image array. I mean, not image array, but first of all, I'm reading this image using OpenCV. So if I right now try to print this image, like saying something like this, plt.imshow, and what was ARR not defined? What's the it's img ARR. So if I right now visualize it, you will see that OpenCV loaded the image in BGR format, but Matplotlib is printing the same image in RGB format because nowhere in the array it was said that this is an image or this image is in which kind of format, RGB, BGR. BGR means blue, green, red. RGB means red, green, blue. So what we're gonna do is we're gonna go to Google and find a solution for it. And simply really we will say that opencv convert BGR to RGB. And any kind of link you can open. There is this one line code that I'm looking for. Right here is the function to do that. cv2 dot color BGR to RGB. This particular function will change the formatting. So this right here is the line. cv2 dot cvt color, take the image array, cv2 dot color underscore BGR to RGB. This particular array will convert the BGR image to your RGB image. And then I can use plt.imshow. So I'm creating a function called anything really. I can call it anything. This function apple mango doesn't really matter what the function name is, but usually we select something like this cv2 underscore imshow, because over in Google Colab there is this in not inbuilt I would say. In Google Colab there is this function called cv2 underscore imshow. And in Google Colab, this is how you display. In Google Colab also, Google Colab CV2 I am show. So you have to import this particular function from google.colab.patches. Yep. From google.colab.patches, import CV2 underscore I am show. But this works only in Google Colab, not anywhere else. So better is to just rely on your custom functions, create your own custom functions, convert it into the RGB format and use matplotlib to display it. That's it really. All right. PGR RGB. What's going on? Okay. Then over here, I've just created a function to just compare the two images, like what the initial image was and what the RGB image looks like. Both are the same array, really. It's just that we are visualizing them in a different format. Both are the same array. All right. So now, initially, remember that we were trying to print an image of 3. So it wasn't really looking like a 3, but if you assume this is a 3, then we will move on and come to this single channel images. So first of all, I'm creating a single channel image by calling np.zeros. Then then I'm filling the relevant elements with 1, and then uh, because it's just a 0 and 1 and it's also a float, so I can visualize this and take a look. Now this at least looks like a 8. You gotta believe this is a 8, right? And what about 3D color channel? I mean, what about 3D images? So let's say I'm creating a np.zeros, 3 rows, 2 columns, and 4 elements. So 3 rows, 1, 2, 3, 2 columns. I mean, this is not a row column format, but this is very tricky. So the outside dimension is 3. 1, 2, 3. The second list like bracket dimension, the two list like bracket dimensions are 1, 2, 1 and 2. All right. Then the last dimension, that is 4, that is 1, 2, 3, 4. It's confusing really, right? Even I got confused by it. And if you visualize something like this, like let's say if you put random numbers over here, I'm putting just the value of 100 in the first cell and I'm visualizing it. Let's say I'm taking an np.array and only this particular element I'm converting it to 100 and rest of it are zeros. So depends on which library I'm visualizing it. So if I'm using matplotlib, so matplotlib works in RGB format. So this is the blue. So first pixel is this, second pixel is this. So I'm making the second pixel blue. So now if I visualize it, you will see this entire image with blue in the second element or second pixel, you can say. And right now I'm only using 1, 2, 3, 4, 5, 6, 6 pixel. Even though 1 pixel is plotted very big, but pixels are the smallest unit of light you can imagine in a display. So smallest unit of light, not unit of light, but smallest, you can say screen of light. So basically, what I'm saying is in a 6 pixel screen, make the second pixel blue. Over here, I'm saying make the first pixel blue. This is the first pixel RGB. I'm making the first pixel blue. So, and this is blue because right now I'm using matplotlib. If I were to use something else, like let's say CV2, oh yeah, actually, opencv also has a function called cv2.imshow, but sometimes it does not work in your notebook format. So, fingers crossed. So, I'm taking this sample array and using cv2.imshow. Yep, I knew cv2.imshow wouldn't work. Okay. No, maybe this is a syntax error. cv2.imshow, cv2.imshow function. And for, oh, it needs a window name and then the array. Okay. So it's slightly different. Is so the cv2.imshow is used inside the scripts .py scripts. So it needs a window name. You can put any kind of name, window name, Apple I'm putting. And it says the kernel crashed while executing code, blah, 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 because this particular function is supposed to work in the Py scripts, not IPYNB formats. So I'm gonna go ahead and run all the cells above. Okay, I gotta restart the entire thing now. Restart and run all the cells above. All right. Now, see, take a look. What we are doing is making the first element RGB. So, making the first element red, the second element more red because the values are going from 0 to 255. So, the 100 value is something in the middle. So, over here, try this exercise on your own. First column pixel RGB. So, a less middle kind of a red. So, dark red, very bright red. This would be uh, kind of a dark green. This would be very bright green, and same for this. And the third last column pixel, the third last pixel would be like a dark RGB, so dark blue, which is right here. And this one is the bright and RGB blue, so bright blue over here. Try it on your own. So there's a practice assignment as well. To go on ahead and try to change the different values over here and see like what comes where. So let's say if I am to change this last element, I could say let's make the last element red. I'm using PLT. So PLT works in RGB. So 255. Let's see. I made it red, right? So to go around, play with something like this. And by the way, if you don't remember like which GitHub repo I'm using, I'm just using Cookie Sensei 14-day bootcamp. You can go over there and make your own fork and work on it, right? So OpenCV, write to disk. You just Google search write to disk, and it will tell you like how to write to disk. And there is this just one line code cv2.im write. So what I'm saying is os.path.s file. If the file already exists, delete the existing copy and create for me. Otherwise, just create a new one. That's what I'm saying quickly. Define a function to save image. You can on your own do that. Crop a image. Basically, cropping an image means zooming in into an array. So let's say if you crop an image like this, what exactly this is? This is nothing but indexing of an array. So I'm running this. Like let's say I'm saying 0 to 400 on the row side. 0 to 400 on the row side. Oh yeah, one more thing. In images, your vertical axis is the x-axis and your horizontal axis is the y-axis. So kind of like your vertical axis is your rows, just like you have in pandas. rows like one, two, three, and the columns are like on the horizontal way. So one column, two column, three column, four column, so on. So what I'm saying right now is uh fetch the rows 0 to 400, 0 to 400, fetch the rows, and fetch the columns 200 to 500. Maybe the 200 part isn't really that clear, so I will say 0 to 500. Now you see. So on the row side, I'm taking 400 of the height. So my point is, row represents the height and column represents the width. Just like you have in your data frames, that row represents the height and column represents the width of the data frame. In the same lingo, you have this. A lot of times people get confused, like why the first thing is something else and why the second thing is something else. So image convolutions, you can try to read the rest of it on your own. How to rotate an image, just Google search. How to blur the image, Google search. Really, how to like do the edge detection, Google search. Sharpen the image, Google search. Box blur, Google search. Image pyramids, Google search. So rest of it, read it on your own. And let's close this video at the moment, and we will start anew with, we will, on the next video we will discuss, mm, in the next video really what we will discuss is something like reshaping of images. So that's like put one image over another, how to work with images really. So yeah, I'll see you in the next video then. All right, bye bye.